So the next topic is circular motion. Okay. So circular motion is the motion along a circular path. If an object is moving in circular path, we call it as circular motion. Okay. So forces are of different types. If I am pushing this, it will be a push. If I am pulling, it is a pull. So if an object is moving in circular path, there will be a force responsible for that. That force we call it as centripetal force. Okay, so when an object is moving in a circular path, we call it as circular motion, and the force responsible for circular motion, Fc, we represent it as Fc, that is known as centripetal force. So centripetal force is responsible for circular motion of an object. Now what will be the equation of the centripetal force? You know the normal force F is ma. F is equal to ma as per Newton's second law. We derived F is equal to ma. Now what will be the expression for centripetal force? So centripetal force is also m into a, but that acceleration will be the centripetal acceleration, v square by r. Okay, centripetal acceleration is v square by r. So centripetal force Fc is given by mass into centripetal acceleration, that is m v square by r. So that is the expression for centripetal force, where m is the mass of the object, v is the velocity of the object, and r is the radius at which the object is getting rotated. Now let us consider a few examples. An object or an object, a stone tied to a string or moving in circular path. This is circular motion. So here centripetal force is actually provided by the tension on this string. This is a string and the stone is attached to the string and the stone is getting rotated due to centripetal force, and that centripetal force is provided by the tension in that string. Now another example, the satellites uh, rotating the earth. The required centripetal force is provided by the gravitational force. So gravitational force will be providing the centripetal force in case of that satellites. Now, if you are moving in a car, if the car is taking a circular turn, in roundabouts and round there are circular turns. So the force responsible for the circular motion is centripetal force. So the centripetal force in road in case of a car, so taking a circular turn, the required centripetal force is provided by the friction. So friction is providing the centripetal force in case of car taking a circular turn. Okay, so that is about the basic thing about circular motion. So circular motion is the motion around a circular path, and the force responsible for circular motion we call it as centripetal force. Now the expression for centripetal force is mv square by r, where m is the mass of the object moving in circular path, v is the velocity with which it is moving, and r is the radius. Now for a car taking a circular turn, the centripetal force is provided by the friction between the road and tire of the car. Okay, so in this chapter we have to study the circular motion of a car on a level road and a banked road. So first of all, I will explain what is a level road and what is a banked road. So this is a level road, that is the road is like this. The road is flat like this and the road is making a circular turn. So the inner end and the outer end of the road is of the same level. There is no height difference. It is level. Okay, it's a level road and it is a circular turn on that level road. Now banked road means this is level road. Now, banked road means the outer surface of the road will be at an angle. This is level road, but outer surface, if the outer surface is making an angle, so this is little raised. This road will be like this, and it will be a curve. In flyovers and all, you will see the round flyovers. So it will be a banked road. So this end will be in a lower level, and this end will be at a higher level. So the outer end of the road is at an angle. It will be making an angle with the inner edge. Inner end. So it will be making an angle theta. That angle theta is known as banking angle. Okay, so such roads we call it as banked road. Okay, so we have to find. So if the car is moving on a road, and if the car reaches a roundabout, normally the driver will slow down, or if it is taking a curve, the driver will slow down. The reason is there is a maximum velocity with which you should take that circular turn, otherwise the car might slip. So here we will be studying what is the maximum velocity with which the driver can take a circular turn on a level road as well as on a banked road. Okay, so first we will see circular motion of a car on a level road. Okay,